Good afternoon, everyone. My name is Sam Fawcett. I'm from Plymouth Marine Laboratory, and we've had a couple of presentations today already covering certain aspects of smart sound. So I'm going to be presenting here a slightly more strategic, high-level view about where where we've been so far, and really where we're moving towards future outcomes, those kinds of things. So. Some of you will have been around this morning when Sarah and Charlie gave an overview of particularly the subsurface network, so the nodes down the bottom there, but this is the main graphic to demonstrate all the assets that we've really got sort of out at sea, at least within the smart sound ecosystem. So we've got some of the surface assets there. One of the main linchpins really is the L4 buoy, which is the one on the far left. That serves as really the primary communications channel within the smart sound ecosystem. So via that L4 buoy, we can have two-way communications between sensor technology as well as autonomous vessels. And then when you link that again with the subsurface network, you can actually extend that communications range through to the subsurface vessels that could be testing the trial or operating in the area. And you have again that two-way communication system to send and receive instructions and data and provide sort of software updates potentially as well. We would describe it as the UK's premier test range for all things to do with ocean technology. It's been very active. We've been conducting trials of autonomous vessels in this ecosystem now for a few years, up to as recently as this morning. The team texted me about 45 minutes ago to say that they're all off the water and all safe and sound. So we had a successful marine trial completing this morning with cracking technology. One of the main positive aspects, or one of the main things specifically to do with smart sound, is the fact that it's built on something called the Western Channel Observatory. So Tim Smythe gave a presentation yesterday about the Western Channel Observatory and its importance, but the sort of short version of that really is that the Western Channel Observatory is a very, very long-standing time series for the collection of marine oceanographic data. So people have been collecting data in the Western Channel Observatory for in excess of 100 years now, particularly that L4 site, and because of that, it's extremely well characterised and one of the best understood bodies of water, particularly in the country, if not in the world. So when we're operating with new kit and new technology, new sensors in particular, we're really able to provide a good overview and a good comparative analysis between the performance of new sensors and the performance of the traditional sampling methods. So Quest, our research vessel there, goes out to the L4 station once a week, usually on a Monday, tries to go out to the E1 station, which is right on the bottom left over there. We aim to get there once a month. It's a little bit weather dependent, so not quite so much over the winter. But you can see just the proximity really between where Quest is actually conducting her scientific sampling and data collection and where we've got the L4 buoy put on station. So we're able to really provide that in a comparative data analysis. So just to kind of cover a little bit about the kind of aspects of smart sound that we've been focusing on up until this point, and we'll continue to do so. Specifically things like how can marine technology, latest marine technology and marine autonomy really be used to support operations at sea. So be that sort of scientific data collection through to things that are a little bit more adventurous like pipeline inspection, etc. How can autonomy be used to aid that activity, and how, where is appropriate, maybe using autonomy perhaps more of a force multiplier instead of an alternative. So you can see in this picture there, we've got Quest out doing regular sampling, we've got the L4 buoy doing some sampling there as well, and we've got a fleet of eco subs that are autonomous. They are actually subsurface vessels, but you can't take a picture of them when they're under the water. So they're on the surface, but they're collecting scientific data alongside all of that. So how can these marine autonomous systems be used to aid how we conduct these previously? What are the implications of this? So if you're conducting the service of data collection with marine autonomy, how are you actually going about that? What are the implications of it? What do you need to really consider? So there's lots of potential advantages, longevity in terms of collecting data for a long period of time, or increased spatial, be able to collect data over a larger area, or perhaps the same area but in sort of finer detail, for example. How does that factor in? Where do you consider those things? And then actually going into the demonstration of it. So it might be a private sector company coming to us and saying, we'd like to demonstrate capabilities of our vessels. Of course, we can help with that, that's no problem. But actually, if you want to demonstrate perhaps more on the communication side, maybe have a proven vessel, we can help with that as well via the L4 buoy. And really start to kind of demonstrate and build up a picture of how these vessels are going to function, and again, how they're going to compare to the kind of previous traditional sampling methods as well. So that's kind of where we're at now, and just coming into a bit more about future outlooks and where we're trying to go with this. So Smart in particular, like I said, we've been conducting testing and trialing with people for a number of years now. And I've been describing this to people as sort of ad hoc testing. So people will come to us and they'll say, we'd like to conduct this trial or this test with this vessel or sensor, whatever it might be, and we want to do sort of these things to demonstrate that capability, and that's obviously fine, we'll continue to do that. But what we're actually moving towards now is slightly more structured testing programs, whereby people will not necessarily come to us with a good idea of what they want to demonstrate. They'll actually enter into more of a structured testing program, structured testing regimen. So we've got a couple of programs to kind of get this going. So the first one you mentioned, something like the Marine Regulatory Innovation Framework, or the MRIF project, working closely alongside Asher Steer Consulting as well as the University of Plymouth. And the aim of that particular project is to try and get autonomous vessels out, particularly surface ships, at a kind of earlier stage of technology readiness level than they're currently able to do so because of the regulatory landscape, which I won't go into too much detail about. But the idea being that vessels need to get out, they need to do R&D, they need to demonstrate or not demonstrate capability. And at the moment, there's not a particularly good mechanism for doing that until they're at a kind of commercially viable state. So the MRIF project is trying to target specifically that area of development and try and get companies through that process and up towards kind of commercial readiness. The second project to mention is has been covered already in a presentation this morning by Andre Burgess, but that's the Marine Autonomy Assurance Testbed. And that particular project, working very closely alongside the National Physical Laboratory, leading it, aims to really target the taking commercial products and going towards demonstrating or assuring the capability of those vessels. So developing from, I've got this vessel through to this vessel is now certified as clear and able and demonstrated to do these certain behaviours or activities or whatever it might be. We're also working very closely alongside partners in defence. So we've heard a few people mention about things like dual use technologies. We're working very closely to do, there's only so much I can say about it, but similar styles of projects and getting technology through and demonstrated and showing capability, but more along the defence line. So the behaviours being demonstrated by the vessels you might expect are going to be slightly different when it's operating on the defence side as opposed to a civilian side. And we're in some quite advanced conversations with particularly the defence primes as well as the Navy on how we can really enable that and make that happen, and what specific things might be demonstrated as well. So that's really it I wanted to say. So we're moving towards that structured testing. If anyone's got any questions, I think best to come up to me afterwards. I'll be happy to answer them. There's some colleagues as well. So with that, thank you very much, and I'll see you in a second.